All right, in our last video, we had looked at the derivative of the exponential function, 2 to the x and 3 to the x, and also e to the x. In general, if f of x equals a to the x, then f prime of x is the natural log of a times a to the x. We're going to do some examples. I would encourage you to try these examples on your own first, and then perhaps go back and watch the video and see that you got the correct answers. All right, so f of x is 4 to the x. F prime of x is the natural log of 4 times 4 to the x. If f of x is e to the x, f prime of x is the natural log of e times e to the x, which is just e to the x. If f of x equals 6 to the x, the derivative is the natural log of 6 times 6 to the x. F of x equals 8 to the x, the derivative is the natural log of 8 times 8 to the x. F of x equals x to the 4th. This is not an exponential function, this is a polynomial, or a power function. So we're going to apply the power rule for x to the 3rd. F of x is pi to the x. That's a constant to the x power, that's exponential. So its derivative is the natural log of pi times pi to the x. 7 to the x has a derivative of the natural log of 7 times 7 to the x. F of x equals 9 to the x has a derivative of natural log of 9 times 9 to the x. If f of x is equal to x to the e power, this is not an exponential, this is a power function. Its derivative is e times x to the e minus 1. Okay, number 10. F of x is equal to 2 times 3 to the x power. Remember, just as in if y equals, let me fix that up here. If y equals a times f of x, its derivative, y prime, is a times f prime of x. Same rule applies no matter what function f of x is. So here we have a coefficient times 3 to the x. Its derivative is the coefficient times the derivative of 3 to the x, which is the natural log of 3, times 3 to the x. You could also say this is the natural log of 9 times 3 to the x, using your logarithm rules and bringing the coefficient up to the exponent. Okay, f prime of x for number 11. We have two pieces. We have an exponential function and a power function. The derivative is the natural log of 2 times 2 to the x plus 2x by the power rule. Number 12, again, we have an exponential function. Oh, this time minus an exponential function. So the derivative is the natural log of 4 times 4 to the x minus the natural log of 3 times 3 to the x. Number 13, we have an exponential function and a power function. The derivative of e to the x is e to the x. The derivative of negative 2x cubed is negative 6x squared. Number 14, again, we have an exponential function. It's been shifted 3 to the left, but that does not affect its derivative. Its derivative will be the natural log of 2 times 2 to the x plus 3. So the derivative is also shifted to the left. All right, f prime of x for number 15. We have e to the x plus pi. The derivative of e to the x is e to the x, so the derivative of e to the x plus pi is also e to the x plus pi. All right, I think those are all of our examples for the derivative of the power of the exponential function. Okay. All right, we're going to start looking at the derivatives of functions that we haven't yet learned, which will lead to the product rule and the quotient rule. Okay, but in this first slide, what we're asked to do is make a guess about what we think the derivative of this function will be. So I like to think about simpler problems that we've had before, right? And so for this first question, it says f of x is 2x plus 1 squared. And I could certainly FOIL this function, right? Expand this function and call it 4x squared plus 4x plus 1. And know, oops, not the derivative yet, and know that we could take the derivative and get 8x plus 4. Or if I factor that, that's 4 times 2x plus 1. Okay, so that's kind of doing it a longer way. There's a shorter way that we will learn. All right, let's take a look back at the function f of x is 2x plus 1, the quantity 2x plus 1 squared. And let's think about what the power rule would say. The power rule would say, okay, I get to bring that exponent down in front and decrease the power by 1. All right? Now, if I compare the derivative after expanding to the derivative that I've made a guess about, right, using the power rule, it's not quite the same. I do have a factor of 2x plus 1, so that's good. But my coefficients are different. The coefficient 4 is twice as big as the coefficient I got using the power rule. Okay. Where do you think that extra factor of 2 came from? Okay, the extra factor of 2 came from the derivative of that inner function, 2x plus 1. Okay, let's try another one, just to see here. So I'm going to expand 2x plus 1 cubed, and if you recall, a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. We'll use that binomial expansion to write g of x in expanded form. So g of x would be 8x cubed plus 3 times 4x squared plus 3 times 2x plus 1. All right, simplifying a little bit more, we get 8x cubed plus 12x squared plus 6x plus 1. All right, just using the power rule, our derivative would be 24x squared plus 24x plus 6. All right, I am going to factor as best I can. Pulling out a 6, we're at 4x squared plus 4x plus 1, plus 1, yeah. Okay. All right, will 4x squared plus 4x plus 1 factor? I do believe it will factor into 2x plus 1 squared. Okay, so that's kind of the long way. I'd like to see if I could apply the power rule to my original g of x function, 2x plus 1 quantity cubed, to see what its derivative might be using the power rule. So I would say g prime of x, bring that exponent down in front, reduce the power by 1. Okay, let's take a look here. A lot of it looks okay. 2x plus 1 squared, 2x plus 1 squared. But again, my coefficients are different. How is the coefficient 6 different from 3? Well, it's differing by a factor of 2. Where did that factor of 2 come from? It's going to come from the derivative of the inside function, 2x plus 1. All right, h of x is 2x plus 1 times x squared minus 1. All right, let me just make a guess at this, okay? Is the derivative going to be the derivative of the first function, right? I could call this like f of x and this guy g of x. So is h of x the derivative of f of x times the derivative of g of x? All right, so my hypothesis, my guess, might be that h of x is 2 times 2x, or 4x. Okay, could you think about this function, h of x, and think about what degree this function is, and therefore think about what its derivative, the degree of its derivative should be. So h of x is really a cubic function. All right, and its derivative, therefore, should be a quadratic function. Oops, h prime of x should be quadratic. All right, so looking at this guess, I'm going to say that our guess is wrong. My guess is wrong because I know that the derivative has to be a quadratic. Okay, so there's something else that's going on when we have the product of two functions in order to find its derivative. Okay, so here we go. Here's the product rule. All right, if f and g are both differentiable functions, and here we have the function f times g, the derivative is f prime times g plus f times g prime. Now it really doesn't matter how you order these. I could have said f of x times g prime plus f prime of x times g. Either way, you write it. You'll get the same answer since we're adding the two products. Okay, so this is the product rule. And how would we prove this product rule? We'd probably have to use our definition of derivative. To prove it. And here we go, the definition of derivative. I won't have enough time in this video to do this, so we'll pick up with the proof of the product rule in the next video.